So today we're going to talk about solving systems of equations, specifically systems of linear equations. And the definition of a system of equations is two or more equations with the same variables. To solve a system of equations with two variables, find the ordered pair that satisfies all of the equations. So what we've done before is find ordered pairs that satisfies inequalities when we just kind of did some trial and error to figure out what ordered pairs satisfied an inequality. We can do that with equations too. So if you look at the red equation, some ordered pairs that would satisfy this equation is if x was 4 and y was 1, 4 plus 1 is 5, so the ordered pair 4, 1 would satisfy that equation. Or we could say 3, 2. 3 plus 2 is 5, that satisfies the equation. Or maybe even 0, 5, that satisfies the equation as well. 0 plus 5 is 5. With the blue equation, x minus y equals 1, we could do 4, 3, because what's 4 minus 3? Well, 4 minus 3 is 1, so that satisfies the equation. We could do 3, 2. 3 minus 2 is also 1. Or we could get really creative. We could say something like, oh, how about 2 minus 1? That also equals 1. Not really creative, but it works as well. So 2, 1 is also satisfied the equation. That should be 2, 1, not 2, negative 1. Not to confuse you. There we go. 2 minus 1 is 1. So there's lots and lots of different ordered pairs that satisfies each equation, but notice that there is only one ordered pair that satisfies both equations, and it's 3, 2. 3 plus 2 is 5, 3 minus 2 is 1. And that's what we're going to be doing today, is trying to figure out ordered pairs that satisfy systems of linear equations. I'm going to talk kind of fast today, so there's a lot to cover. If you don't, if I go too fast, remember you can pause the video, you can rewind it, slow it down, watch it as much as you want. So we're not going to just do some random trial and error like we did up here on the red and the blue equations. We do have 3 different ways that we're going to solve systems. This video is going to cover one of them. It is solving the system by graphing. And it's exactly what it sounds like. To solve a system by graphing, we're going to graph both of the lines on the same coordinate plane. Where the two lines cross is going to be the solution to the system. So, solve the system of equations by graphing. The first one is 2x minus y equals negative 1. So to solve that, we would subtract 2x from both sides. That would be negative y equals negative 2x minus 1. And then we do have to divide by negative 1 to eliminate that negative sign in front of the y. So we get y equal to 2x plus 1. And then we can go and graph that. So to graph that, we would have to put a point on the 1. And then from that point, we'd have a slope of 2. So up 2 over 1. Up 2 over 1, and as many times as we want to do, up 2 over 1. And then we draw the line through those points. So I'll try to draw a straight line. There we go. There are a couple of arrows on either side to show that it goes on forever. And then we solve the blue equation. So the blue equation is 2y plus 5x equals 16. To solve that one, we're going to subtract 5x from both sides. Solving it for y again so we can graph. So 2y equals negative 5x minus 16. Divide by 2. So we get y equals negative 5 halves x. Remember, I like fractions. And negative 16 divided by 2 is negative 8. So then we're going to graph that equation. Come on. So we're going to put a point on negative 8. And then from that point, we're supposed to go down 5 and to the right 2. But if we go down 5, you see that we quickly run out of room. So instead of going down 5 and to the right 2, that's the same as going up 5 and to the left 2. 5, 1, 2. There's my second point. And then I will draw that line. There we go. Put the arrows on there. And again, we're going to try to figure out exactly where those two lines cross, and those two lines cross right here. And it looks like that ordered pair is -2, -3. That is the solution to the system, -2, -3. So don't just stop at the graph and say you're done. Identify the ordered pair that is a system to the solution, or the solution to the system. And that is the only ordered pair that fits both equations at the same time. Again, there's lots of ordered pairs that works for the red, lots of ordered pairs that works for the blue. Only one ordered pair works for both of them. Let's try another one. So the next example, we're going to solve both of those for y. So we will add 3x to this one. So that'll give me 8y equals 3x plus 36. Divide by 8. So y equals 3/8 x plus, now 36 over 8, that's 9/2. Simplifies to 9/2. It's about 4.5, and we'll need to know that for graphing purposes. And then do the same thing for the other equation. And this one's going to be easy to solve because all we got to do is subtract 6x from both sides. And because then it's already solved, because y is by itself already, y equals -6x minus 21. So we do have a little bit of an issue on this one, because notice on the red equation the y-intercept is -21, and the graphs that I give you don't go down that far. So if that's the case, if that happens, just change the scale. So you're going to have to kind of scratch out the numbers there, and we're going to go by each block is going to be worth 2. So that's going to be -4, -8, -12, -16, -20. This will be 4, 8, 12, 16, 20. So 4, 8, 12, 16, 20. And -4, -8, that's a -8, -12, -16, and -20. So now we graph them. The blue equation is 3/8 x plus 9/2. Now 9/2 is about 4.5, which is going to be about right above the 4. Whoops, that is not the 4 anymore, because remember we changed the scales though. So it's going to be above the 4, which is right here now. And since we do have to change the scales the same amount, we can go ahead and count blocks. So we can go up 3 from that point. So 1, 2, 3 over 8. 1, 2, 3, 4, 5, 6, 7, 8. Place our second point over there. And let's go ahead and draw that line. Okay. And then we do the same thing with the red. So with the red equation, we have to go all the way down to -21, which is just a bit below the -20. And I can't go down 6 into the right one, so we're going to go up 6 into the left one. So 1, 2, 3, 4, 5, 6. Remember, it's okay to count blocks as long as the scales have changed the same. So I'm going to draw that line. There we go. Look to see where the lines cross. They cross right here. Now we did change the scales. Again, they cross right here. We did change the scales, so what point is that? So that is -4, +3. -4, 3 is the solution to that. A couple of special case situations that you might run across is on these. Again, the directions is still to solve by graphing. So when we solve the first equation by graphing, we can add 2x to both sides. So that'll be 5y equals 2x plus 5. And, excuse me, 2x plus 10. That's a 10. Then divide by 5. I was thinking about the 5 too much. So that gives me y equals 2/5 x plus 2. So 2/5 x plus 2. Make that x there. So put a dot on the 2. We can go back to our regular scale. We got room for it. We'll go up 2. over 5. 1, 2, 3, 4, 5. Place a point there and draw our line. Draw a line right through there. And now do the same thing with the other equation. And so we will subtract 4x from both sides. So minus 4x gives me negative 10y equals negative 4x minus 20. Now divide by negative 10. So y equals negative 4x divided by negative 10 is positive 2/5. Negative 20 divided by negative 10 is positive 2. So we're going to graph y equals 2/5 plus 2. So I go on the 2, place a point there. And from that point, my slope is 2/5, so up 2 over 5. And, look what happened. When I draw my line through there, they're the same line. They're exactly the same. It's like one line is kind of laying on top of the other and they're touching each other at multiple points. Well, that being the case, we have a special name for this. This is called the infinite solution. And that's how you would state it. Infinite solutions. What that means is that there are multiple ordered pairs that satisfies both equations. Lots of them. As how many of them? Well, infinite of them. So then we have another special case, and we're going to solve this one graphically. So we have 6x minus 4y equals 15. So we will again solve for y. So subtract 6x. So minus 6x minus 6x. So that's going to give me negative 4y equals negative 6x plus 15. Divide by negative 4. So y equals, that's negative 6 over negative 4 is positive 3/2. X. And 15 divided by negative 4 is just going to be negative 15/4. Do the same for the other equation. We will add 6x to both sides. So we get 4y equals 6x plus 18. Divide by 4. And we get y equals 3 equals, let's try that again. There we go. 3/2 x plus 9/2. Okay? So to graph these, we'll go with the blue equation. And on the blue equation, it's down at negative 15/4, so that's about 3.75. So I'll place a point there. Then we'll go up 3. 1, 2, 3 over 2. Connect those. And with the red equation, we do the same thing. So I'll place a point at 9/2. That's about 4.5. About right there. Go up 3. 1, 2, 3 over 2. There's my second point. And connect those. We're going to do green this time, because my red has disappeared. Kind of weird. Okay, so what do you notice about this one? On this one, it appears that the lines don't cross, and they don't, because the lines are parallel. You might have been able to recognize that because they both have the same slope. So here's the slope of 3/2, here's the slope of 3/2, but we can see it on the graph as well. Well, since they don't cross, we say that there is no solution.